Hi, this is an analysis for an AC analysis, and this is a two-stage Mosfet to find the parameters we want, which is Rn, Rout, and then the overall gain, which is V0 over Vsig. So to start this, we want to determine the AC parameters GM, and that needs the values from the DC analysis of either VGS or ID. So the equations for GM can be seen here. Here's one, and here's the other. And so depending on what values you know, whether it's ID or VGS, you can determine GM. So plugging in these values, 200 microamps per volt squared was given for the Kn prime. VGS was stated as 2, and then VT is 1, so minus VT here. For this one, we have 2 and 200 for Kn prime W over L, and then we use the ID value given to us. So that results in 200 microamp per volt for the first transistor and 6 milli for the second transistor. So next we want to find Rn and Rout. So we notice that Rn is located here and it is pointing in. It says to ignore the input source Vsig, so we're going to ignore that, and we're going to find the input resistance. And it's a little unclear here, so please ask me in class if you include this or not. And what I actually wanted was from this node to ground, so ignoring part of this 10 ohms too. So if we ignore that, then we just see that yes, it is just a 1 mega ohm resistor. So Rn would be 1 mega ohm. And for Rout, that's going to be at this node to ground. And we see we have a pathway there and then a pathway here. Pathway here will give 100 ohms. And recall the derivation for what the equivalent resistance you see on the bottom side of this dependent source is going to be 1 over GM. And it doesn't matter that there is other resistance, so this is going to be 1 over GM. And that was always true no matter what circuit you had over here, whether it was additional resistors or not. So this has then just 100 in parallel because they split, so that would be a parallel form, and then 1 over GM. So again, Rn was 1 meg, and then Rout was 100 in parallel with 1 over GM2, and that gave a value of 62.5. Next, we want to find the value for Vout over Vsig, and so in order to do that, we need an equation for Vout in terms of Vsig. So here we notice that all the current comes down and goes through this transistor, and VGS2 is going to be VG2 minus VS2. And I'm just going to draw these up here. This will be VG2 minus, and then I'm going to call this VS2. So Vout here is just going to be that current times that resistance. So here's our equation for Vout, and it's a positive GM2 VGS2 times 100 because the signs are the same. Here you see yes, plus to minus, and the Vout is plus to minus. Then we need VGS2, which is VG minus VS2. And so VG2, we again see there's just one resistor here, so the current is going to flow up this way, and it's going plus to minus, and our node has to go from plus in reference to ground, which would be the minus. So they're opposite signs, so we get a negative GM1 VGS1 times 2K, and that is our VG value. And then it's minus this value, Vout, which we already found as GM2, VGS2, 100. So now we want to lump all the common terms together, and we have a VGS2 on this side and a VGS2 on that side, so we need to bring this one over to the other side, and we get VGS2 plus the GM2 VGS2 100, and then we can lump that up and divide by that quantity. And then on this side is the minus GM1 VGS1 times 2K. So this gives us our VGS2 equation, but we notice that VGS1 is not determined here. So to find VGS1, we locate where it is. Again, we need to take VG1 minus VS1. And so to do that, VG1, you can see, is a voltage divider of Vsig times 1 meg over 1 meg plus 10. VS1 is easier because it's just already shorted to ground, so VS1 will be 0. So here it's written down VGS1 is VG minus VS, and then here's the voltage divider, 1 meg over 1 meg plus 10. And since 1 meg is so large to 10, in comparison, that's pretty much just Vsig. So now we go back to the Vout equation, and we're going to substitute in that VGS2 quantity that we saw. And plugging that in, we get the GM1 2K Vsig over 1 plus GM2 100. And VGS1 was just Vsig, so that's why that's plugged in there. Now we can divide by Vsig and multiply out those quantities, and that ends up giving us a minus 0.15 volt per volt. This concludes this solution. Thanks for watching.